AB Calculus lesson on derivative of logarithmic functions. Okay guys, we do have a warm-up. Please, we're going to work on that in class, but it'll be good for you to take a look at it before we begin. But here is our lesson. Okay guys, there we go. So we have a definition of defining a logarithm of base a with respect to x, and that yields this right here, 1 over x times ln of a. The second question of the warm-up will actually lead you to this point, right? Now, looking at this, there's an implication here, right? Now, when we do this over here, this implies that ln of x is 1 over x, because when you have d dx of, let's say, log of x is equal to what, guys? d dx of log base e of x, which is 1 over x times ln of e, and we know that the ln of e is 1, therefore it's 1 over x, right? Now, using the same definition as this over here, if x is like a u, a function, we got to multiply that by u of x, and this is essentially what that is saying. So if instead of being x, it's some function of x, you do have to follow up by doing the differentiation. But if you think about it, this one already has it done, because when you do the derivative with respect to x over the x, that's equal to 1, right? Anyways, using that information, let's get this done, shall we? All right, guys. In this particular case, what we have is what? When we do dy dx, according to the rule, what do? I see whatever the x is over here is 1 over that times ln of the base, which is 2 in this case, right? So this is a variation from your textbook question. So whatever the input is, u, right, u of x, this will be 1 over u times ln of the base, in this case is a, times du dx, right? If the u is x cubed plus 1, du dx is 3x squared, right? So now we substitute all the values, right? And that'll be 1 over, let's see, what is the u here? Okay, got it. X cubed plus 1 times the log base 2 times the du dx is what? 3x squared. Therefore, dy dx is equal to 3x squared over log 2, log 2 times x cubed plus 1. You either show your work that way, or what I would expect to see is something to this effect, okay? Or dy dx is equal to, like, let's say you could do this in your head, x cubed plus 1 log base 2 times d dx of x cubed plus 1. I would like to see that actually, right? So that I know that you understand the process, right? All right, guys. So when you go through that calculation right there, you could do the derivative of the x cubed plus 1, which is 3x squared over log base 2 x cubed plus 1. All right, guys? All right. Let's do the next question, shall we? So the next one is dy dx, using the second approach, is 1 over sine of x plus log of base. In this case, its natural log is e. You don't have to write this particular step, right? Times the d dx of sine of x. And we know that sine of x derivative is negative cosine of x over sine of x right here, guys, right? So what does that give you? If you said that is cotangent, right? Ooh, I made a boo-boo. Right, the derivative of the sine is just cosine of x, right? So therefore, dy dx is equal to cotangent of x. All right, guys? All right. So let's do the next question. The derivative of the next one, this looks like the more like a reminder from the previous material. So let's get at this. So in this particular case, the dy dx is equal to, copied as it is, but multiplied by the derivative of the base, log of the base, which is 3. I meant to say ln of the base, right? Because if it was base e, it would cancel out, right? Remember that? And then we would do derivative of the ln of the x. So therefore, let's clean this up. Dy dx is, that part right there is what? 1 over x? Yes. So what we end up with, ln of 3 times 3, base 3 of ln of x divided by x. And that would be the answer. Okay, guys? All right. So let's move on to the next page, shall we? Let's see, where are we? Yeah, that was my key, just in case. There you go. So what I want you to do is pause the video, guys, and work on these two problems. Now, what I want you to do is, clearly, when you do this, this would be 1 over this times the derivative of that, which you have to use a product rule. And you know it could get pretty messy, right? So instead, what I want you to do is use the log property, if you could remember what those are. If you don't remember them, you should look it up. And then split this up into using the logarithm properties, and your problem's been much, much easier. Okay, guys? All right. In case you downloaded early, before I corrected it, that is 1 plus x in the denominator. Okay, guys? Pause the video and start working on this. All right. So we have... This is what we did. So what I did for the first one, I just went ahead and did it without using the log property. And this is what you get. 1 over this times the derivative of that, which is the product rule. And u, this is a v, and the uv prime, which I wrote down over here, plus v u prime, which I wrote down over here, guys, right? I noticed that these have x cubed, sign of x in common, factor it out. And then I just pull that out from the bottom here as well, and they cross cancel, and you're left with this. And then what you could do is simplify that even further, and you should, in this case. This is so much, it looks so much simpler, doesn't it? It's 2 cotangent of x plus 4 of x. This is a lot of work, right? There are lots of little places where you could make a mistake. However, if you take ln of both sides, right? And that really should have been ln here as well. My apologies. No, sorry, I'm thinking about something else. So when you use this, the ln of a times b is ln of a plus ln of b, but I pulled out the exponent to the front, right? So when you take the derivative of that, that's 1 over x. When you take the derivative of that, it's 1 over sine of x times the derivative of the sine, which is, this is the one that we did earlier, right? Yeah, that's it, we're done. It is really quick, isn't it? Right? The example C, very similar. Using a log property, you know that log of a over b is log of a minus b, right? Log of b. And then I pull out the exponent to the front. And then it's very simple stuff right here, right? 1 over 1 minus x times the derivative of that, which is minus x. Same thing over here. And that, ooh, boo-boo. I forgot that I changed it. So that will give you a minus sign, right? So what that will give you is that will be also a minus sign over here. Of course, now that has to change. All right, so that will be minus 2 minus 2x minus 3 plus 3x. That will give you x minus 5. There you go. Okay. Yeah, so doing this using log property makes many things a lot easier, right? So let's talk about this. What is the derivative of the y equal to x to the n using the power rule, that is n times x to the n minus 1. Sometimes students get confused because it is something to the power of something. But in this particular case, that is an integer. Or it could be a real number. It really doesn't matter, right? And the base is the variable. Here in exponential form, that's been swapped. So that is the a is the all real number, and that's the variable, isn't it? For that particular case, what do we do? Yes, the y prime was a of x, right, times ln of a, wasn't it? All right, guys. So let's take a look at the progression of a logarithmic differentiation, right? And we should take a look at the progression of the exponential form in this case, okay? So in this case, we've got number to the number. We have a function to the number, which was this case right there. And that here is just constant, right? That's just constant. So y prime is equal to what? 0. This one, y prime is equal to b to the f of x, b minus 1 times f prime of x, right? And this here, y prime is equal to what? A to the g of x times ln of a times g prime of x. This is the question mark. We have a variable to a variable, or you could say function raised to a function. In those particular cases, what we're going to do is we'll take ln on both sides, and then one of the best properties of the ln is that you could bring down the exponent down to the front. Then we're going to use the implicit differentiation, and then we'll remember to substitute the y back. Okay, let's try this, shall we? So we have y here is equal to ln of x to the cosine of x. If we ln both sides, it's going to be cosine of x times ln of x. Let's do ddx of both sides. Then that becomes 1 over y times y prime. And then it's cosine of x ddx of ln of x. We're using product rule, right? We've got ln of x. Oopsie. That is pretty bad writing. Times ddx of cosine of x. So let's take a bit of a breather and take a look at what's going on. All right, examine this a little carefully. Right. Now, once we do this, we realize that this is nothing more than we can forget about what's inside. Think of that as f of x, right? And then let's do that one first, shall we? Let's focus our energy on the two most important part here, this one and this one. And I will put that right below that space, right? And that's going to become ln of whatever's inside would be 1 over whatever's inside, which is ln of x, times the derivative of that, ddx of ln of x, which is simply what, guys? That's 1 over x, isn't it? Right. So I'm going to write down 1 over x over here, okay? At this point, we should be able to do these. That'd be cosine of x, and that will be ln of x times negative sine of x. Now, what we're going to do is, after we do all this, guys, right? What I was actually planning to do was like this, and then we're going to multiply y to both sides, right? So it's y times all that, isn't it? So therefore, dy dx is right now in the cleanup mode and substitution mode. So the y is equal to right here. So we're just going to copy that over, and that is ln of x to the cosine of x. If you want to put parentheses to make it more obvious, that's great. Times the parentheses, the bracket, I'm sorry, and that'll be cosine of x over x times ln of x plus, oopsie, negative sine of x over ln of x. You see that, guys? Yeah, that's how you do it. Okay. All right, so that's what that is. What I want you to do now, what I want you to do right now is take time to these two, right? And see how things go. So these problems are slightly simpler than the example that I gave, right? All right, guys, pause the video. All right, guys. So now that we're back, let's look at this individually. Oopsie, why is this so slow? Here we go. There you go. So we ln both sides, that comes out to the front, and then we need to do a product rule here, isn't it? So what you can do is just add these, guys, right? So that is the u. So u prime is equal to negative sine of x. And then v prime is equal to 1 over x, right? You should probably write that down, right? And what you could do instead is maybe call this thing, instead of doing this, right? Make it a little cleaner, right? So what you could do on the side, let's use just a slightly different color. Call this u, call this v, just like the way I'm doing right now. And the u prime is equal to negative sine of x. And the v prime is equal to 1 over x, right? Just as a reminder, right? And then the rest you could say u v prime plus v u prime. Plug it in, and then we move the y to the other side, and we simplify the expression, and that's what we end up with. Okay. The third example was same thing. Once again, what you can do is maybe call this the u, call this the v. The u prime is equal to 1. The v prime is 1 over sine of x times the derivative of that, which is negative cosine of x, which will be, hold on. No, why am I keep doing this? All right, which would be cotangent of x, right? There you go. All right, guys. So we know that, so now we know what to do, right? So it's a u times v prime, right? Which gives you that, right? And that ultimately becomes this. And then if you did this over here, you could actually ultimately gone straight from here to here, right? Anyways, once you simplify all that, substituting back for the y, that's the answer we have. Last question. Your turn. Yeah, this thing looked nasty, didn't it? Right, because if you did it just a straight quotient rule, you would have to square that times, now, in the denominator, right? In the numerator, it would be that times the derivative of this, which would have been what? A product rule. I suppose you could simplify that too, but it's hard to. And then minus that times the derivative of that, which would have given you a, what do you call that? Chain rule. Now that problem could have been a little bit more difficult by me putting something other than 3x plus 2. However, if you ln both sides, bingo, boom. That was it. Because it'll be that minus that, and all I did in each one is pull out the exponents. That's right. Exponent of that is the power half, right? And then we did the derivative of that, which is 1 over x, and the derivative of that is 1 over x squared plus 1 times the derivative of that, which is that. That'll be 1 over 3x plus 2 times the derivative of that, which is 3. And the rest was just me collecting stuff together. And that was it, guys. That was it. All right, guys. So I'll see you tomorrow. Bye-bye.